problem is, what is the smallest positive integer n for which there exists another positive integer a such that a and a plus 735 are exactly n divided. Okay, that's a lot to take in. You have to really think about what that problem means. But understanding the problem, the first step of the problem, are pretty much going to be the same in a lot of cases, right? Look for like small values of n to see what it means in a very specific and concrete situation. So what if n was 1? Okay, so what is the, so is 1 the, so, okay, and 1 is obviously the smallest positive integer. So if n was 1, it would definitely satisfy that, right? So if n was 1, okay, and there exists a that has one divisor and a plus 735 is 1. I mean, the thing is, numbers can only have one divisor if their number is 1, right? So if n equals 1, then a must be equal to 1. And then a plus 735 has to equal to 1. But it's not, it's 736. So that's a contradiction, right? Okay, so what if n equals 2? So then there would have to exist an a with 2 divisors, which means a has to be prime, right? N equals 2, and then a is prime. Okay, and then a plus 735 is also prime. Yeah. So one thing you might want to check is just check for an easy prime you have, right? Like you did. So a is equal to 2, for example, which is prime. And then a plus 735, 737, and you got to wonder if that's prime or not. Okay. Well, it's obviously not divisible by 2, 3, because it adds up 17. 5 doesn't end in 5, or 0. And 7. If you 7, okay, minus 700 will be 37. 37 is not divisible by 7. So it's not divisible up to 10, okay? But can you see it's actually divisible by 11? Right? So 737, if you divide it by 11, what would you get? So 73, 7. Yeah.
66.
You get 66. I'm just dividing without actually telling you what the quotient is. That's what modular arithmetic really is. You just care about the remainder.
Yeah.
That's 7, 7, right? So there's no remainder. So it's divisible by 11. And it would be like 67 times. Yeah? Okay. So it's no. It's divisible by 11, right? Right? Okay, and then you could think, okay, what if a was the next prime, like 3? Okay. I add 3, well 738 is obviously not prime because it's even, right? Oh, but then you realize any time I have a prime that's odd plus 735 is going to be even, right?
Yeah.
So then it can't be prime. You know? So therefore n can't be 2, right? So then maybe, you know, following this progression, what about n equals 3? Okay? And you know, what would it mean if n had to be equal to 3? If n was equal to 3?